All right, here we are moving along with all of our work in percent in Mod 5. So I want you to take out your notes packet, and I'm going to leave my screen this way so that I have access to the calculator when I need to. I'm going to make sure I've got that one up here. There it is, our handy dandy TI. Okay. And we're going to start off right away with what's our essential question today. So we're going to rewrite percent equations or expressions in a way to help us solve percent problems. So how do I rewrite expressions to solve percent problems? Here we go. We have a lot of terminology in here. Not all of this terminology may or may not exactly be in your textbook, but I definitely want to talk about these. Okay. Wholesale price. Your book might call this original cost at some point. So here's how I want you to think of it. This is the price that the store owner or the store company, corporation, whatever, think of it this way. It's the price that the store owner pays for some sort of product. So let's pretend we're going to open up a store and we're going to sell fancy schmancy sunglasses, okay? I'm not making the sunglasses myself. I have to go buy them from some distributor. So I'm going to contact Ray-Ban or some of these other glasses companies, and I'm going to say, hey, I want to sell these. So I'm going to pay, maybe I'll pay like $25, $30. Let's say I pay $30 a pair for these sunglasses. That's called the wholesale price. What I'm going to do, so let's say I buy some sunglasses over here and I pay $30 for these sunglasses. Now, I am not going to sell them in my store for $30. Heavens, I've got to make some kind of money off the deal. I've got to pay my people. I've got electricity. I've got computers and cash registers and all this stuff that I have to pay for, and the rent for my building space. So my retail price is the price that, if I think of it from the store owner's perspective, this is the price the store owner charges now for the product. As a customer or a consumer, this is what we, the customer, pay when we walk into a store to go buy something. So you walk into a discount store somewhere and you want to buy your bottle of Mountain Dew for $1.29, let's say. Okay, the store didn't pay $1.29 for that bottle of Mountain Dew. Who knows how much? Maybe they paid 70 cents or 50 cents or whatever. They're turning around and upping the charge so that they can make some money. All right. So this is a price. This is a price. Sale price. Hallelujah. That is, as a customer, this is happy news. This is a price that has been decreased. So it's actually, I should write it this way. It's a retail price that has been decreased in some way. Maybe it's just going on sale because the store decides to put it on sale, like a weekly advertisement or for Black Friday or something like that, has been decreased to a new price. There we go. Cool. It could be with a certain percentage. It could be a specific amount. It just kind of depends on the individual situation. But the sale price is this new price that's been decreased in some way from the retail. The last two things we have to talk about here are markups and markdowns. A markup, and in our study of this or dealing with it, we're going to consider it as a percentage rather than just a flat amount. So we're going to say it's a percent increase. And it's usually to that wholesale price. So we're marking up the price. It's a percent that something is increased. A markdown or a discount, in our case, is we're going to talk about it as a percent that we decrease. I'm going to add the word add up here. And here I'm going to say subtract. Okay. As we start to do some of these, it'll start to make a lot more sense. Okie dokie. Let's move on in your notes. Here's the first example. Okay. So to make a profit, stores mark up the prices on the items that they sell. So we have a sports store and they buy skateboards from a supplier for, let's say, S dollars. We don't know what it is. Okay. So this is how much I'm paying for something. They're going to call that S. This bar here, I want you to write that this is 100%. Okay. They're saying that they are going to mark up the price 42%. So this next box under here, I want you to write 42% on top. Okay. That is about not quite half again as much. Okay. So I'm going to put an S on here as well, just to indicate that this is 42% times S, I think. Let's see, how do I want to write that? Let's write it next to it. Maybe that'll be better. Okay, so this is 100% times whatever that skateboard cost. And then I'm going to mark up the price. So this is the markup. Okay, this is 42% times whatever the price is. Now, a markup means we're going to add them together. Okay, so you're going to take your original price, that's the 100%. You're going to times the price. This is the 42% times whatever the price of that skateboard is. And that is going to give us what we are going to charge, or in other words, what that retail price is altogether. So let's first take this situation. What if it's $35? Okay. So we're going to start with $35. That's 100% times 35, which is just going to be 35. Then we're going to increase this price. I guess I can leave this here now. Okay. We're going to increase it by 42%. So now we have to take 42% times 35. All right, grab your handy dandy calculator. 42%. I'll use the percent button. I don't really like doing it, but I usually just put in the 0.42 for the decimal. $35 equals 14.7 is what my calculator says. That translates to $14.70 in money. Okay. Since this is a markup, we're going to add those two together to get our final retail price over here is $49.70. Boom chakalaka. Okay, cool. What if it was a fancier skateboard and it was $56? Well, then I'm going to have to take 100% times $56. Let me boost this up a little bit. Jinkies. I'm trying. Let's see if I can add some room to this screen. I think I have to go full screen to extend here. There we go. All right, 100% times a $56 skateboard is $56. We are going to mark up the price 42%. So take 42% times 56. Let's calculate that one. All right, I'm not going to switch out my screen to go and grab that calculator. So I want you to go ahead and grab your calculator and figure that out. $23.52. That's the markup at 42% of this skateboard. That was $56. Add those two together and we get $79.52. That's the price tag we're going to throw on that skateboard as we go to sell it in our store. All right, that's what markups look like. You end up starting with your 100%. That's your price you paid for it. You're going to take a percentage of that cost. That's the amount of the markup. And then you're going to add that on to get your retail price that you're going to sell it for. You add them together. In this case, you have 100% times your skateboard price plus another 42% times your skateboard price. Really, we're taking 142% times the skateboard price. And by the way, as a decimal, that's 1.42 times S. That's how you could do it all at once on your calculator. Let's look at another one. Rick buys remote control cars to resell. He applies a markup of 10%. So let's think about what this means, because it says it wants two expressions that represent the retail price of the cars. All right, so first of all, we've got to figure out what is our car cost. Let's start with just the letter C for the cost of the car. Okay, here we go. So I'm going to start with my car right here. I have to add another 10% times whatever the cost of the car is to get my ending price. Now remember, this was plain old C or 100% of C. That gives me my ending amount. Let's go back here and look at, I think doing part B first might be easier. Okay. If we start with $28, 100% times 28 is 28. I'm going to add 10% times 28. You see how I'm just using the $28 for my variable? That's $2.80. What do you end up with at the end? Add those two together and I get $30.80. Now, I've just answered part B. $30.80 is his selling price. What are the two expressions that represent the retail price? Well, you could think of it this way. 100% times C plus another 10% times C, or actually it looks a little nicer to write these as decimals. So you just write 1C plus 10 hundredths or 1/10 C. That's one way you could write it. Or if you added that all together, 100% and 10% is 110% times the cost of the car, which as a decimal looks like this. You could write it like this. So here are the two kind of expressions, or sometimes you might like to think of it kind of like a formula because we still have a variable there. And here's how you figure it out when you plug in 28. You know, just to check so you can see that instead of finding that markup separately and then adding, if you did it all at once as 110% times the $28, you get to your answer right away. So let me show you what that looks like. 110% times $28. It actually is going to figure out that $2.80 and automatically add it in there to get $30.80. Well, hot diggity dog, huh? There you go. We are going to use the same idea with markdowns, okay? But let's look at one more example. An exclusive clothing boutique triples the price of the item it purchases for resale. Okay, so let's hold on and think about this. So that means if I buy something for $10, I sell it for 3 times that amount, for $30. So I'm starting at 10. I end at 30. So how much did I change it by? 30, 10. So I went up $20. That's the amount that I changed. What is this percent of the change? You take how much did it change divided by the starting amount. 20 over 10 equals 2 as a percent, that's 200%. That is the boutique's markup. Okay, write 2 expressions that represent the retail price. Well, I started here. We have to pick a variable. So if I call this like X, that's my starting amount. I'm going to add on there 200% of X. So here's my 100% X. I'm going to mark it up 200%. That gives me 300% times what my original price was. And instead of writing it as a percent, if I just simply write it as a 1x plus 2x, you could think of it that way, or just plain old 3x to figure out the ending price. Holy cow. You know, I don't know so much about clothes, but I do know that jewelry has a crazy markup as well. All right. Let's talk about markdowns. So let me get my mess out of here because I didn't erase all this from what I had done before. Okay. All right. Take a look at your notes. This says that a discount store is going to mark down or put on sale all of its holiday merchandise by 20%. Let's take a look at what happens when we mark a price down. Here's our regular price, 100%. We are going to take and give a 20% discount. When we take a discount, we subtract it out of there. Okay? So if I was starting at $16, if I took 100% of $16, that's my starting price. 20% times $16 is this amount in this chunk here, and we're going to subtract this off of our existing price. So grab your calculator and figure that out. That's $3.20. You can write that on there if you want. When you subtract these two, this is what your sale price is going to be. $12.80. That's the amount that goes here on what's left of this bar. This green part is the $3.20 that you're chopping off the price. These two together give you $16 whole. So really, you start out with 100% of the price, you take 20% off, you're really only paying 80% of the price then. All right. It says run this scenario where you had $23. So let me get this mess out of here and let's try it with some different numbers. Okay, so instead of 16, we'll go back to this. If you want, why don't you go ahead and draw another picture of rectangles right here. So what if it was $23 to start with? Okay, 20% of it's going to get taken away. Take 20% times 23 bucks. You should get $4.60. That's how much this is. Subtract those now. Because it's a discount, you get to take that off of the price, and you are left with $18.40. That's how much is left over here, $18.40. This was the what, $4.60? And when you add all of this together, you should get back to your original amount of 23 bucks. There you go. Markdowns, think of subtracting. Markups, think of adding. There we go. All right, let's take a look at this one. A bicycle shop marks down each bicycle selling price B by 24% for a special sale. Let's draw a model to represent this. So what I want you to do in this box is draw a rectangle on here. leave some space in the middle, and I want you to draw the same exact rectangle underneath. Now, 24%. In the middle, we're going to draw what approximately 24% of this is. The top is the whole price, the 100%. Smack dab would be 50%. A fourth of it would be 25%. So we're going to do pretty close to a fourth, okay? This is 24%. I don't know what the price is here. I just know that the full selling price is 100%. 24%, to figure out that amount, you'd have to take 24% times whatever the price was. In this case, I'm going to leave it as the variable B. Underneath here now, color this in. This is what you're going to subtract away from here. So this, we're taking 100% of B and subtracting 24% of B. And that'll tell me what's left here for your sale price. Now, if you just take a look at this, 100% minus 24% of anything leaves you with 76% of B. So that would be the expression we could write here. This is the 24%. This is the 76% here. That adds up to the whole 100%. Instead of using the percent symbol, I'm going to use the decimal and write it that way. Or I suppose you could write it as a fraction if you want, but in this case, I'll write it that way. All right, one last scenario here. Jane sells pillows. For a sale, she marks them down 5%. Write two expressions that represent the sale price of the pillows. Well, we need a variable to stand for the original pillow price. I'm going to use P since we have pillow prices. And here's one way to do it. You have 100% times your pillow price, and your discount is going to be 5%. You're going to take 5% times that price. Or if you want to use decimals, you'd write 1p minus 5/100ths p. That's one way to figure it out. Or the other way is do it all together at once. 100% minus 5% is 95% times the price of the pillow. Or as a decimal, 95/100ths times p. So if the original price of the pillow is $15, what's the sale price? Well, I start at $15. We're going to subtract whatever 5% times 15 is. Figure out what that is on your calculator. I need more room. This happens to be 75 cents. So $15 minus 75 cents should give you $14.25. Bing! You could have figured that out using this idea where you would take 95% times your original $15. And if you take 95% times 15, shazam! You end up with your final answer right away. And you kind of bypass that step of finding what the discount is. Cool beans. All right, well, I think I'm ready to turn you loose. So what I want you to do is check on Schoology for what your assignment is going to be in this section. Good luck, and may the force be with you. Watch. And most of these are money, so please make sure you watch how you're going to round off your pennies if you end up with 3, 4, 5 decimals. Okay? Cool beans. Good luck.